You know, in any factory, some costs are just obvious. You see them right there on the balance sheet. But what if one of your biggest expenses was totally invisible, hiding in plain sight, in the very air you use? Well, today we're going to pull back the curtain on the massive, hidden energy cost of industrial compressed air. And, maybe more importantly, show you how to stop paying it.
So you've probably heard of the big three utilities, right? Electricity, water, and gas. Well, in the industrial world, there's a fourth one, compressed air. It's the powerhouse behind everything from painting cars to packaging your food. But here's the thing, this utility has a dirty little secret. It is incredibly energy hungry. And a huge chunk of that energy, it literally just vanishes into thin air before it even does any useful work.
All right, so here's how we're going to break this down. We're going to go on a little 5-step journey. First, we'll get a handle on this invisible energy guzzler. Then, we'll walk through what an energy audit cycle actually looks like. After that, we'll talk about the global standard for getting it right. Then we'll get into the cool tech that makes it all happen. And finally, the best part, the payoff.
Okay, let's dive right into our first section, the invisible energy guzzler. So, what's the deal here? What makes compressed air such a huge hidden drain on a company's resources?
Get this. In a lot of factories, the air compressor system is one of the biggest, if not the biggest, energy hog they have. Okay, now imagine this. Because of things like tiny leaks, inefficient use, or just a bad setup, up to, get this, half of all that compressed air just disappears, gone, along with all the money and energy it took to make it. That's the scale of the problem we're talking about. And the very first step to plugging that leak? You guessed it, an energy audit.
Which brings us perfectly to our next section, the energy audit cycle. The whole idea here is to make that invisible problem visible. And this isn't about a one-time fix. No way. It's about building a system to constantly keep an eye on that energy waste and keep it under control for good.
And this is so important to get. A real energy audit isn't a one-and-done kind of thing. It's not a project with a start and end date. It's a continuous loop, a cycle of constant improvement. You don't just find a leak, patch it up, and call it a day. The goal is to build a process, a habit of always monitoring, always improving, and keeping that system running at peak efficiency.
And this whole process follows a really classic, super effective model. Plan, do, check, act. It's pretty straightforward, really. First, you plan it all out. What are your goals? Then you do it. You actually implement the plan, take your measurements. Next, you check your work. How did you do compared to your goals? And finally, you act on what you found, making those improvements, which of course brings you right back to the planning stage for the next cycle. See, it's a loop.
So this whole plan, do, check, act thing, it's not just some good idea someone came up with. It's actually the backbone of a globally recognized playbook for managing energy.
And that playbook is called ISO 5001. You might have heard of ISO standards before. Well, this one is all about energy. It's basically an international rulebook that gives any company, big or small, a proven step-by-step framework to manage their energy use. So instead of just guessing or trying random things, you have a solid, repeatable system designed for long-term savings.
And what makes ISO 5001 so powerful is just how thorough it is. I mean, we're talking about way more than just taking a few measurements. It helps you set up your key performance indicators, your KPIs. It helps you establish a baseline so you actually know if you're making progress. It even helps you define who on the team is responsible for what and how to plan your audits. It's the whole shebang, a complete system.
Okay, so we've got the process, plan, do, check, act. And we've got the standard, ISO 50001. But how do you actually do it? Let's get into the nitty-gritty and look at the tools that turn all this theory into real-world, data-driven action.
Right, so how do you track this stuff in real time? I mean, it's the old saying, isn't it? You can't manage what you don't measure. And in a huge, complex system like a factory, you need that information live, as it's happening.
Well, it all starts with the hardware. And the cool part is, it's non-invasive. We're talking about smart sensors, like digital power meters that watch the electricity, and flow meters that track how much air is actually moving through the pipes. You don't have to shut anything down. These things literally just clamp onto the existing equipment and immediately start sending back live data.
And we're not just talking about sticking a sensor on one compressor. Oh no! They go everywhere. On the dryers, the cooling towers, even on valves way out in the facility. Each one of these sensors is a tiny data point. And when you put them all together, you create this incredible digital twin, a complete virtual live picture of your entire system.
So all this data from all these sensors gets beamed to one central hub, and this, right here, is where the magic happens. All that complicated raw data gets crunched and turned into this beautiful, easy-to-read dashboard. All of a sudden, a manager can just look at a screen and see everything. Total power, total flow, how efficient the system is at a glance, right now.
Which brings us to the final, and let's be honest, the most important part, the efficiency payoff. After all this work, what do you actually get? What are the real, tangible results? Look, having a cool dashboard is great, but just looking at data doesn't save you a penny. The real power, the secret sauce, is in the analysis. It's about digging into that data, finding the patterns, spotting the waste, and using it to make genuinely smarter decisions.
Okay, so take a look at this chart. This is a fire hose of raw data from 180 days. You've got power up top, flow on the bottom. And, I mean, honestly, it just looks like a bunch of squiggly lines, right? Just noise. There's ups and downs, but you can't really tell what's going on. It's pretty much useless like this.
But check this out. Watch what happens when we look at that exact same data in a different way. Instead of a timeline, we're plotting flow against power, and boom! All of a sudden, that random noise snaps into a clear pattern. That cluster of dots, that's your system's efficiency sweet spot. And every single one of those little dots floating far away from the group, that's waste. That's a red flag. That's a specific moment in time you can go investigate and fix. Now that is turning data into something you can actually use.
The difference here is just night and day. You go from a before state of just pure guesswork where everything is inefficient and costing you a fortune to an after state where you're in complete control. Your system is measured, it's optimized, it's cheaper to run, and every single decision you make is backed up by cold, hard data.
And the payoff isn't just about saving money on your electricity bill either. This whole process ends with getting an official certification. It's like a seal of approval. It makes that invisible performance suddenly very visible and very real. It's no longer just an idea, it's a tangible, certified asset for the company. It's solid proof that your system is running at a top-tier level of efficiency.
So, there you have it. We've seen how a smart, systematic approach can shine a light on these huge, hidden costs. And it really makes you think, doesn't it? What are the invisible costs, the hidden drains on energy or time or money that are hiding in our own world, in our own jobs, maybe even our own lives, just waiting for us to finally measure them so we can start to manage them?